Hello everyone. Hope everyone is staying healthy and happy. The topic for today's lecture is going to be on plotting. If you go through the course schedule webpage, you'll see that there are going to be four lectures on plotting. What is weird is the first lecture on plotting is sort of interleaved in between the database lectures. That's actually my bad. Uh, when I initially put up the schedule for CS220 this semester, I took Tyler's schedule from the last semester and translated it as such to take into account this semester's schedule. When I went through the schedule, it was too late for me to fix this switch. Tyler had to make the switch because of Thanksgiving break, but there was no reason that we needed to have the first plotting lecture interleaved in between the database lectures. My apologies for that. That said, let me actually talk a little bit about plotting and why it is significant enough to dedicate four different lectures. So in the past, I've mentioned that plotting is this cool tool which allows you to visualize your data sets, right? Why is that so important? Recall that human beings in general like visual things and textual things. For example, let me talk about a Google search. So let's say that you're trying to do a Google search about something, and imagine the situation where you have to open a browser and instead of typing www.google.com, imagine if you had to type in the IP address for Google every single time. That's horrible, right? Every time you'll have to remember a bunch of numbers and keep typing it correctly to ensure that you go to google.com. That's not something which humans would prefer, because humans prefer English alphabets over remembering a bunch of numbers. Similarly, rather than trying to find answers to questions by looking at just the raw data set as such, it's very helpful for human beings to visualize the data sets using plots. And another reason why plots could be very useful is because plots can help you win arguments. For instance, let's say you have to present something to your manager in your company. It's very easy to convince your manager if you can show visual representation of your argument and saying that, okay, look at this plot, this is exactly what I'm saying, and these are how the numbers talk in terms of the data set. It's just very easy to use a visual representation to convince other people. All right. There could be multiple different plots that you can create with any given data set. For example, you can create a pie chart or a bar chart or a line chart or a scatter plot and many other things like that. So, what is the key thing with plotting is that writing code for creating such plots is actually very easy. You just can live with doing a set of Google searches on like what function call you should make and what parameters you need to tune. So what is so difficult about plotting is that given a question, how do you actually determine which type of plot is the best plot that you can create in order to make a convincing argument? So that's going to be the main takeaway that you're going to get out of these plotting lectures that we are going to be covering. All right. So the first thing that I want to mention with respect to plots is a module called matplotlib. If you're familiar with the programming language called MATLAB, you know that you can actually create a set of plots using MATLAB. Somehow, the Python module for creating plots, which is matplotlib, the most famous module, which is matplotlib, is quite similar to what we have in terms of the plotting functionality from MATLAB. So we are actually not going to be directly writing code um, to plot using matplotlib. Instead, what we are going to do is we are going to leverage the fact that pandas module integrates with matplotlib. This is going to be something similar to what you've seen with SQLite 3. Pandas integrates with matplotlib just as it integrates with SQLite 3. So we are going to use pandas series and data frames to create all the different plots that we can possibly create. But we are also going to fine tune a lot of options using the matplotlib way of configuring things. So we are going to be seeing how to do some settings using matplotlib as well. All right. That said, let me talk a bit about today's readings. So today's reading is going to be a HTML file. So this was created by Tyler. So if you think me and Mike are doing a good job with this course, that's majority of the credit goes to Tyler. So we are very grateful to have all this readings which were pre-prepared by Tyler. So you can go through the HTML file for the reading, or if you want to explore the notebook that was created to generate the HTML, you can go to the notebook IPYNB link, and then if you scroll all the way down, it's gonna be the notebook on matplotlib -intro. So I'm sure you went through the pandas intro notebook during the previous lectures. All right. So for the plotting lectures, we are actually going to be doing hands-on coding. So there are no slides for today's lecture. Instead, I'm going to actually do the entire lecture using notebook demonstration. All right. So the first thing that I want to do is to import pandas. So let me go ahead and import pandas as PD, and I'm also going to import data frame and series, just so that I don't have to keep saying that every single time. Alright, so let me go ahead and create a series using a list. So recall that you can create series both using lists and dictionary. I'm going to get started with just a simple list based series. Let me have three entries. Let the first entry be 5 million, three more zeros, and let me actually have two more entries, and I'm going to change that to 3 million and 2 million over here. All right. Recall that when you create a series, actually let me go ahead and display S before I talk about it. So recall that when you create a series, you have two different ways of accessing the data. So the first one is using something called as index. That's going to be similar to keys in your dictionary. Somehow they renamed it to index. So the second way to access your data is going to be through an integer position. So integer position is going to be similar to your index in your list. So recall that when you create a brand new series with a new list, both your index and integer position are going to be the exact same things. All right. So and I've created the series using integers. So the data type here is going to be int64. All right. So let me go ahead and show you how to create plots using pandas data frame and pandas series. So the way this is going to work is, if you have a series, you're going to say series.plot underscore function, and this is going to be a function call. Similarly, for a data frame, you can say data frame plot function. And what are some types of plot functions that you can use would be pie for pie chart, and scatter for scatter plot, and bar for bar chart, and line, and so on. So as I sorry, I didn't actually mention this before. So today's lecture is going to be about pie charts and bar charts and scatter plots. So I'm going to briefly introduce scatter plots, but we'll be looking at pie chart and bar plot in detail. All right. So let me actually get started with pie chart plotting. So what I'm going to do is I'm going to say from the series S, I want to plot a pie chart. So this is how you can create a pie chart. So one thing that you'll observe is if you just run this piece of code, that's going to just show you what is being returned by this function call, which is an access subplot object. But Notebook actually doesn't know how to display the very first plot directly. So you'll have to do something which is called as a setting in matplotlib and say matplotlib inline. So the term inline refers to the fact that you want to display your plot within your notebook itself instead of opening it in a different window or save it in a different file, let's say with a .png extension or .gif extension. All right, so if I go ahead and rerun this, now you'll notice that the plot actually gets displayed. The weird thing is that after this problem persists, not persists, this problem happens only for the very first plot that you create. For all other plots, somehow Jupyter Notebook knows to display the plots in line. So just to get your very first plot displayed, you'll have to use this setting. All right, so let's take a look at this plot over here. What are a few pitfalls with this plot is that I have no idea what I'm displaying. It just says like 0, 1, and 2. And another thing is I cannot actually read the absolute numbers for each of these entries, which is which makes the plot very much unreadable. So I'm going to go ahead and actually convert my initial series into a dictionary instead of a list. So let me say that let's suppose this is all these numbers are the amount of money spent by some departments. Let me first convert this into a dictionary. So I'll be replacing that with curly braces, and we of course need keys for each of these entries, right? So what are going to be the keys would be the department names. So let's say the first department is police and the next department is fire, and let's say that the third one is going to be schools. So let me go ahead and do the plot again, the pie chart plot again with this dictionary. So as you can see, now it's slightly better to read because I'm able to tell which department spending each of those pies represent. It's still not very clear as to what these numbers are in terms of the actual spending for each department, right? So often pie charts are not really good for visualizing any information which has which requires you to talk about specific numbers. So what you need to do instead is you need to use the bar chart. So let me show you an example of the bar chart first. So as you can see, the bar chart clearly displays the amount of spending done by each of these departments over here, right? So, if you're being picky, there are still a lot of things missing from this particular plot, right? Okay, I can say that, okay, this department has like some number associated with it, but it's not really clear what exactly that number is, right? And other thing which is missing is like what exactly is this plot about? There is no title as such for this plot. So I'm going to actually show you how to tune such parameters using matplotlib. So before I do that, I want to talk about this object that's getting returned by the function call for the bar plot. So as you can see, it returns a axis subplot object. So you should be actually capturing that into a variable if you want to manipulate the matplotlib parameters. So I'm going to call that variable AX. That's the common notation which everybody uses in general while plotting. So I'm going to capture the axis subplot, and I'm going to show you how you can set um, axis labels with it and set title for the plot. So the first thing that I'm going to show you is how to set y label, which is the y axis label for this particular plot. So I do know that these numbers are the dollars that was spent by each of those departments. So I'm going to actually go ahead and label them as dollars. So the next thing that I want to do is I want to set title. So as you'll observe, most of these functions have like intuitive names. So you can just say set y label or set x label or set title. So I'm going to set the title for this plot as annual, let's say city department spending. So if I go ahead and run this code again, as you can see, now the plot has a title and it has a proper label for y-axis. All right. So if you can be a little more picky. One other thing that will probably bother you is that, the y-axis has these huge numbers, right? I told you that I'm typing in 5 million and, 3 million and 2 million initially, but it's not necessary that these are friendly with respect to a human readable perspective. So what we could think of doing instead is we could just take the whole series and divide the series by a number. So let me actually go ahead and first show you that. So you can do things like divide the series by 1,000 or divide the series by a million, right? Sorry, I missed 1 0. So it's more readable from a human perspective to have a number 5 than 5 million, right? So let me go ahead and show you how to do that in the plotting. So you can actually quite easily divide your series by a number and directly plot it without having to store it in a different variable. I'm missing a 0 again. So if I go ahead and display this, now the plot is slightly more readable, right? Because we have smaller numbers. And what is missing now is that the y label says dollar. It's actually supposed to be millions of dollars, right? So obviously we need to fix that. All right. So the next thing that probably might bother you is that the label on the x-axis is actually vertical, right? That's again something which is difficult to read. So I'm going to quickly show you how you can orient the label, but I'm not going to talk much in detail about that. So you can use a function called as set underscore x ticks tick labels. So X tick refers to these tiny ticks that you see on the x-axis of your plot. So I'm trying to set some parameter for how the label is being displayed, right? So one thing that you need to know is this function call actually needs a list of the labels as the first parameter. Unfortunately, that's a mandatory parameter. So how can you actually extract the key, not the key, the names of the department from your series? So recall that you can actually get the index from a series saying s dot index. So I just need to convert that into a list. So let me actually go ahead and display that first before as you can see, we are able to extract the index from that series. So once we have the index from the series, we can just convert that to a list. And what we really wanted to do was figure out how to change the orientation for the x-axis labels over here, right? You can just use the setting called rotation, which is going to take an angle as value. So I'm going to, as an example, show that you can rotate the labels using a 45-degree angle. All right. The next thing that I want to talk about with respect to this plot is font size. As you can see, the font size is quite small in this plot. Why exactly is this significant? So imagine a scenario where you're inserting this plot into a Word document or a PDF document, and for some reason or the other, let's say you want to print out that document and create a physical copy. So what you'll notice is if you have small font size in your plot, your entire plot becomes completely unreadable. So it's important to have the correct font size in your plots. So in order to do this setting, I'm going to go ahead and import matplotlib. So let me scroll all the way up here. As a good practice, I'll be doing all imports at the top. So I'm going to do import matplotlib. And I'm also going to import from matplotlib something which is called as pyplot. So I'll be talking about pyplot shortly, but I'm going to go ahead and add the import right now. Alright, switching back to the font size setting. So there are a bunch of parameter settings which you can make for matplotlib, which is called as RC params. So let me actually go ahead and first show you what RC params looks like. As you can see, RC params is a dictionary, and it has a a lot of settings for plot parameters. So I'm going to go ahead and comment this. So the parameter which we are interested in setting is the font size. So since this is a dictionary, I'm just going to mention the key as font.size, and let's actually first take a look at what is the default font size. So as you can see, the default font size is actually 10. So let's go ahead and increase that to say 18. I'm going to just reassign the value to 18. One thing that I want to mention here is if you actually go and rerun any of these cells again, now the font size will change according to the setting. Let me show you an example. As you can see, I reran the last cell, and the font size got increased by quite a bit, and you can see the bigger font sizes now. I'm not going to rerun the other cells, but you can try to do that on your own. All right. The next thing that I want to talk about is we saw how to increase the font size. So how can you actually play around with the size of the figure itself? And the setting for that is going to be controlled by an argument to your bar plot function. So let me copy paste the code over here. So let's say that I want to give custom height and width for my plot over here. The way that I'll do that is I'm going to pass a parameter called figure size to my bar function. This parameter takes a tuple. Recall that tuples are nothing but lists which are completely immutable. So the tuple takes like two arguments, which is the height and the width. So the first argument is going to be height. For example, I'm going to pass a value of 3, and let's say for the width I'm passing a value of 4. Let me show you what that does to the plot. As you can see now, the plot size varies, figure size varies according to the parameters that you passed. So you can play around with the values and figure out what values work best for you. Let me actually remove this X label rotation. All right. The reason I removed it is because the rotation made the x-axis a little less readable. One intuitive thing that might occur to you with respect to looking at this plot image is, why is this vertical? It looks like it should be horizontal rather than vertical, right? So how do you actually make your plot horizontal? That's quite simple actually. Instead of using bar, you can use the bar h function, but you need to be really careful when you're switching your plot from vertical orientation to horizontal. As you can see, there are other things that also need a switch along with bar h function call, which is like now you need to flip around your height and width. So now that needs to be 4 and 1.5, And another thing that you'll notice is now your expenditure is supposed to be x-axis, right? So clearly we need to reset the label for the x-axis instead of setting it as y label. All right, that seems to be okay. The next setting that I want to talk about with respect to the bar plot is how do you actually change the color of the bar plot. So you can use the parameter called color, which takes in the value of the color. The value can either be names of colors like red, for instance, and you could also have the first letter representing the color. For example, you can have B for blue. So you might be wondering, if B is blue, what is black? Black is actually K in the world of plotting. Actually, in general, black is denoted by the letter K on a computer. There we have it. So that's how you can vary the color setting. There is one other possible option for color, which is something which is called as grayscale setting. So that will make your plot be black and white. So you might be wondering, wait, are we living in the 80s or 90s? Why are we talking about black and white plots? So the reason black and white plots are still significant is despite the high availability of color printers, a lot of people still prefer to print out documents in using black and white printers. So sometimes you might want to make your document readable to anyone who's actually not sometimes, all the time you would want to make your document readable to people who might print it out in black and white printer. So you might want to have grayscale plots. The way that you can mention the amount of grayscale in your plot is by using a number here instead of a letter. Let's say that if I say the value is 0.5, that's going to be midway through gray. If I mention 1 on the other hand, that's going to be all white. Uh, 0 on the other hand is going to be black. So I'm going to leave this at 0.5 and you can play around with the number as you see fit. Alright, the final setting, final couple of settings which I want to mention with respect to this example is the first one is something which is called as the grid. So one thing that you'll notice is for the schools bar, it's not really clear whether the value is exactly 2 or slightly less than 2 or greater than 2, right? The way that you can make your plot more readable is using something which is called as the grid. Let me show you what the grid does. As the name suggests, it draws the grid for your plot, thereby making it slightly more readable if that is what you prefer. Uh, the next, the other setting which I want to talk about is making your graph as minimalistic as possible. What do I mean by that? So you have like this rectangular box, right? Not all sides of the rectangle are needed. You only need the left margin and the bottom margin to represent the y-axis and the x-axis. You can actually get rid of the other two. Let me show you how to get rid of that. I'm going to go ahead and remove the grid. So you have a setting in axis subplot called as spines. So let me display what, oh, not apines, sorry, that was a typo. If you display spines, you'll see that it's an ordered dictionary which has like 4 settings for each of the sides of the rectangle. So you can actually let me actually show you. Let me show you how to set the visibility of your spine to be false. So since it's an ordered dictionary, let's say I want to set the top spine's visibility to false. I'm going to do that by saying top spine dot set visible to false. And then similarly, I want to make the bottom, not bottom, sorry, right spine also to be invisible, right? So if you do that, now your plot is kind of minimalistic. So you would want to declutter your plot as much as possible so that you can use the minimal display to um, capture the user's attention. All right, that is actually, before we move on from this example, we did do a bunch of settings on this plot, right? Let's say you're trying to generate multiple plots which all should go into a single document. Then it makes sense to sort of have a function which enables you to set some of these parameters so that like all of your plots look similar in terms of all these settings, right? So the next thing that I'm going to show you with respect to this example is like how do you convert all of these settings into a function to make it reusable. So as I mentioned a couple of minutes back, so there is a pie plot um, there is something called a spy plot which you can import from matplotlib. We are going to actually use that to extract subplots from your plot. So let me first show you how to do that. So I imported pyplots as plt. So I can say plt dot subplots to actually get subplots from within a plot. So how do you actually make use of this? So let's actually create a function which will enable us to do the setting after extracting a subplot. So I'm going to call that function get underscore ax because I want to do all the axis subplot settings, and I'm going to go ahead and extract subplots using plt underscore subplots function call. Let me show you what this actually returns. So going back to the previous cell, as you can see, the subplots function call returns a tuple. So the first one is the actual figure and the second one is the axis. So we need this particular parameter. So as you can see, this function call returns two values, right? In a tuple. So you can actually extract that by assigning it to a t and then say that okay, first one is going to be t of 0, which is going to give you the figure, and ax is going to be t of 1. You could do that, or you could do something which is called as tuple unpacking. I'm going to teach you this for the first time. So you can actually directly unpack items in your tuple as you receive the return tuple value itself. So you can just do that by saying I know that there are going to be two items in the tuple, so I can just say uh, assign those values to the variable names fig and ax. That is something that you could do. Uh, what we want to be able to do is now that we extracted the axis subplot, we want to be able to move all of these settings that we do inside the function, right? So let me go ahead and copy paste all of those settings. So let me first actually move these settings which remove the visibility of the spines. What else are we doing here? We are also setting figure size, right? Uh, let's actually move that also in here. We want to have, let's say, parameters for these items instead of, not items, these values instead of hard coding them, right? So you can either get like both the parameters for height and width, or you could just like have one of them hard code and vary the other. So I'm going to actually go ahead and hard code the width, and I'm going to say for the height take the value from the user input. So the reason for that is typically your documents width is usually fixed. You want like all of your plots to have like same width, whereas the height should be varied based on the content within the plot. So let me see, I'm going to have the default value for height to be let's say 3, or like let's actually have it 3. All right. What else are we doing? So these are plot specific, right? So you don't want to be really setting the title and the label inside this function because you want to reuse this function for multiple plots. So let me go ahead and call the function. So the function, before that I need to return ax from the function. Sorry about that. let me go ahead and call the function get underscore ax, and let's say that I want to change the height to 1.5, consistent with the previous example. How do we go ahead and do the plot? Let me copy paste those lines again. So instead of saying let's get rid of all these common settings. Instead of saying you get the axis as the return value from the plot, you want to be able to set the axis as a parameter which you got from your get ax function. So if you go ahead and, sorry, there we go. So if you go ahead and do this, let me go ahead and run it. So as you can see, we still have all of the settings, and we are still able to do that by making the function call over here, and by assigning the axis subplot whatever setting we made inside the function as a parameter to your plot function. That's it for the first example. For the next example, I'm going to be using bus.db. So if you go to the course webpage and click on the data link, you should be able to download the bus.db file from there. So I'm going to go ahead and import SQLite 3 and OS modules. So I have already downloaded the bus.db file to my local folder. So what I'm going to do is I'm going to go ahead and define a variable called path, which is going to contain bus.db, and I'm going to assert that that particular file actually exists. So just to be clear that it does. Alright, so the next thing that I want to do is I want to create a SQLite connection, and I'm going to name the variable as con. So I want to connect to this particular database. Uh, After that, the next function that I want you to recall is the read underscore SQL function from pandas. So recall that this function takes two parameters. The first one is going to be the query, and the next one is going to be the connection. So whenever you're poking around a new database, you need to actually run the SQL query select star from SQL master. So that's what I'm going to do now. So select star from SQLite master, and let's look at what is in there in the database. So as you can see, there are a bunch of tables. So today's example is going to use the boarding table. So let's go ahead and take a look at what is there inside boarding table. So I'm going to say select star from boarding, and let's see. We have a bunch of columns over here. We have the stop ID, where you have the ID of the stop where the bus boards, and the route of the bus, which is, for example, is number 27. And then you have the location, and you also have the daily boardings, average daily boardings at this particular stop, right? So, for example, if you take stop ID 1169 and the bus route 38, on an average around 32 people board it on a daily basis, right? So the next thing that I want to be able to do is I want to be able to capture the result of this query into a data frame. Recall that you can, since this is a big table, you could also use the limit query, not limit query, sorry, limit SQL option to limit the number of rows that gets displayed. Alright, so let me actually go ahead and capture whatever is being returned into a data frame. Alright, so let me jot down what is the question that we are now interested in answering. Let's say that we want to find out what are the top routes and how many people ride those routes, and we are going to answer this question by using plots. So first thing that we want to be able to do is you have uh, the route information at every bus stop, right? So you want to be able to aggregate all of that. So the first thing that we are going to do is we are going to first group our tables, not tables, our table rows by the column route. And what you want to do after you group by the column route, you want to be able to sum up all the daily boardings, right? So let me say we are interested only in the route and sum of all the daily boardings, right? So I'm going to just say I want route and I want sum of daily boardings. And of course, I want a neat name for this new sum column. Let me call it as daily, and let's go ahead and look at what is in our data frame. So all right, as you can see, the sum for each routes is given as part of this data frame. So let's go ahead and visualize the daily column of this data frame using a bar plot. Recall that you can very easily convert one column from a data frame into a series by just extracting that column. So you can just say s equal to df of daily, and you can just say s dot plot dot bar. So as you'll see from the plot, it's actually quite cluttered. There are two different issues with this plot, right? First one is we can't really focus on the routes which are most popular, because the routes are not really ordered by daily boarding popularity. The second problem is that even if we have ordered the routes by popularity, there are still like way too many routes for this graph to be readable. So we want to be able to focus on let's say the top 5 routes. So let's go ahead and fix the first issue by ordering our data by adding a order by clause. So you can say order by daily, and we want to create a descending order, right? That's because we want the popular routes out of this. So let me show you the bar plot that gets generated after we fix this. Sorry about the typo. So as you can see, it's slightly better now because we have fixed the first issue. The next issue which we want to fix is we want to focus on just the top 5 routes, right? We can do that by adding a limit clause saying limit the number of database rows to be 5. That gives us a decent enough plot. But there is still something which is wrong with this plot, which is throwing us off. What is this x-axis value? So is there a route 0? That is not really correct, right? So that information is coming from our data frames index column. So we want to be able to set the route as our index column to our data frame. So let me go ahead and do that. So recall that whenever you're doing a set index in a data frame, you need to save the value which gets generated into the same or another data frame, because it generates a different data frame. So if I go ahead and fix that, there we have it. As expected, route 80 is the most popular route, right? And then you have like 2, 6, 10, and 3, and so on. All right, so we got rid of the two major problems with our plot, but there is still this minor problem, right? We're only be able to visualize what is happening with the top 5 routes. What about the rest of the routes? So how do you actually extract the rest of the routes from the data frame? We can just do things like slicing of our data frame, right? So let me go ahead and copy this over, and of course I need to get rid of the limit 5. So what I want to be able to do is I want to get let's say the top 5 entries alone. So I can just do that by saying I log of give me the slice up to 5th row entry, which is going to be the top 5 routes. So I want to be able to extract the rest of the information, right? So the rest of the information can be easily extracted by getting everything from the 5th row until the end of the data frame. And what do we want to do with this is we want to be able to create a sum of all the daily boardings across all of the remaining routes which are less popular. So I can easily do that by using the pandas sum function call. And what do we want to do with the sum? We want to be able to add another index into the series S called other, right? So we want to say S of other over here is going to be this sum value. So let me go ahead and display what is there in S. So as you can see, now we have the top 5 routes, and we also have a sum of the boarding for all other routes in your data frame. So if you go ahead and visualize, sorry, let me actually just visualize S over here, S dot plot dot bar. So there we have it. Now we have all the information that we need, and let's go ahead and do a few settings. Recall that we can use the get underscore ax function call to have the consistent parameter settings for our axis subplot. So I just want to say ax equal to a parameter ax is equal to ax, and let's say that I want to make my bar chart to have a black color. There we go. A few other things for us to fix. We want to be able to say what is the y-axis label and for this graph, right? So let's go ahead and do that. We'll say set underscore y label, and what is the y label? It's going to be rides per day, and let's actually keep it that way before we fix the scale. So as you can see, the scale is much bigger than human readable number, right? So let's say that we want to divide the counts by 1000, and we can have the axis labels to say thousands. There we have it. We have a much better plot now than before. All right, that's it for the second example. For the third example, I'm going to be actually using a different data called trees.txt. So I'm going to actually copy paste this list from this file into my notebook. So this is just an introduction to the scatter plot. We'll be covering scatter plot in detail in the next lecture. So this is just a custom generated data set of trees where you have an age for each of the tree, and let's say the height and diameter for each of the trees. So for scatter plots, we need to be able to use data frame directly instead of using series. So let me show you how to first create the data frame. So there we have it. So if you go ahead and display the data frame, let me motivate scatterplot before actually showing you how to make scatterplot with this example. So if you take a look at this particular data frame, right, you'll see that for trees of age 2, there are multiple entries over here. So if you do a bar plot, all of these will be represented by a single bar, right, which is not really useful to read into each of these entries. So which is why for such kind of data sets where you have like multiple points corresponding to one particular value of column, you want to be able to do a scatter plot instead of doing a bar plot. So the way that scatter plot works is you need to say df data frame dot plot dot scatter, and it's going to take at least two parameters which are x and y. So x is going to be column name, and y is also going to be column name, which corresponds to both of these x and y axes of your plot. So in this example, I'm going to simply do df.plot.scatter, and let's say that I want to visualize which columns over here. Let's scroll back up. Let's say that I want to visualize age and height. So you can say your x-axis value is age and y-axis value is height. So the reason I'm going with x-axis value being age is it's typical to use time-based parameter as x-axis than on y-axis. I'll wrap up with this, and we'll be continuing this example as part of plotting 2 lecture.